What's up? I'm James Steiner, and I'm presenting for me, Nick Dolan, and Garrett. So first off is homeostasis and feedback loop. This kind of points out the stimulus, sensor, and response loop. In an organism, maintaining stable internal conditions like temperature, pH, and nutrition level is crucial for survival, much like keeping a room at a comfortable temperature. That goes right into our analogy. Think of the body as a thermostat. When the temperature goes too high, the cooling system turns on to bring it back down to normal temperatures. Cells use negative feedback loops to maintain stable conditions. For instance, in body temperature regulation, if it gets too high, the body sweats to reduce temperature and bring it back to a set point. Which brings us to our next point. Methods used by cells to communicate. Right here I have my image of two cells. One's just blobbing around and the other one's pretty confused. So cells need to communicate to coordinate actions and respond to changing conditions, akin to neighbors exchanging information to organize a community event. Our analogy, cell communications is like passing notes between two neighbors to plan a block party. Each cell sends and receives signals to coordinate activities for everyone to participate in. Cells communicate through various methods like direct contact, autocrine, paracrine, and endocrine signaling. Enable them to interact and respond to external cues or internal needs. Next, we have our G protein coupled receptors. Here, two G proteins are about to be a couple. He is asking her to marry him. GPCRs, or G protein coupled receptors, are integral in receiving signals from outside the cell, much like a receiver captures signals from your television. In our analogy, think of GPCRs as the antenna on your TV that captures signals. When a signal hits the antenna, it triggers a response shown on the TV. Just like a ligand binding to a GPCR triggers a cellular response. GPCRs are membrane proteins that activate G proteins upon ligand binding, initiating signal transduction pathways that leads to various cellular responses. Next, we have our receptor tyrosine kinases. Right here, I thought they kind of looked like a hot dog, so that's kind of what I drew. There's nothing really funny about it. But receptor tyrosine kinases, or RTKs, play a key role in cell growth and differentiation, similar to how a blueprint guides construction and development. Imagine RTKs as the blueprint for cellular development. They guide and direct cellular growth and differentiation, much like a blueprint guides the construction of a building. RTKs are cell surface receptors that, upon ligand binding, trigger cascades of signals leading to cellular responses involved in growth, differentiation, and metabolism. Which brings us to our fifth, ion channel receptors. These are really lame because there's really nothing funny about them, so I just drew the plasma membrane and their channel transmembrane protein. So, ion channel receptors allow ions to pass through the cell membrane, akin to opening windows to allow airflow into a room. Picture ion channel receptors as windows. When opened, they permit ions like air to flow in or out, altering the cell's behavior. These receptors open or close in response to ligand binding, changing the flow of ions across membrane and influencing the cell's electrical properties and flows. Finally, we have our rugby passing for signal transduction pathways. So I thought it kind of was like rugby because, like, in rugby they all line up and sort of just pass the ball down the line, similar to what the images looked like. Signal transduction pathways are like a relay race, where a baton signal is passed between team members' molecules until they reach the finish line, cellular response. Or, in our analogy, pass between team members, actual team members, until they reach the finish line or the trizone. Imagine signal transduction as a relay race. The signal baton is received, relayed, passed from one another to another, and then finally results in a response, crossing the finish line. Reception involves ligand binding to receptors. Transduction relays the signal through a series of molecules or pathways, and the response triggers specific cellular changes or activities based on the received signal. In summary, cells maintain stability through feedback loops, communicate using various methods, and utilize receptors like GPCRs, RTKs, and ion channels to receive and transduce signals. Signal transduction involves sequential steps of reception, transduction, and response, culminating in specific cellular reactions or behaviors based on external or internal cues. Thank you.